Hi, I'm Jing Hong and today I'll be going through on Introduction to Sorting Algorithms. So what I'll be talking about today will be the merge sort and the quick sort algorithms. So sorting algorithms are essential tools in comp science and programming as they provide methods for arranging elements in a specific order. So firstly, I'll start with quick sort. So what is quick sort? Quick sort is a fast in-place sorting algorithm for its efficiency in large data sets. How it does is that it selects a pivot and then reorder the array such that all the elements with value less than the pivot goes to a left subarray and all the elements with values greater than the pivot goes to the right subarray. And after this partitioning, the pivot will be in the final sorted position. So we just keep repeating this until everything is sort of sorted properly. Yeah. So this is a recursive approach as you keep repeating the division. Yeah. So how it does is that, as I said earlier, you select an element as a pivot, then those elements that are smaller than the pivot will go to the left subarray, or those that are bigger will go to the right subarray. Then you apply the quicksort algorithm recursively to both left and right subarray, and this will allow you to end up with a sorted list. So this is the code for the quicksort. So let's go through. So this is the line. So what this line does is the terminating case. When there's only one element left inside the list, you return the element. Then for pivot, you're just taking the center of the list. So what this line does is that if the value in the array is smaller than that of the pivot, if x smaller than our pivot, you put it to the left subarray, and if it's bigger, you put it to the right subarray. And if it's the same, you put it in the middle. Then you just keep repeating this until everything becomes middle and you end up with a sorted array already. And now I'll talk about the time complexity of quicksort. So the average case would be O n log n, and the best case, when the pivot happens to be the median or near the median of the array, will be O n log n as well. So the best case and the average case are quite similar. However, for the worst case scenario, when the pivot is the smallest or largest in the array, you cause unbalanced partitions, and this will result in an O(n) squared time complexity, which is quite slow. So what happens is that if it's the biggest, then everything in the element will be smaller than the biggest pivot. Then the element, because it's the biggest array, so everything will move to the left subarray. Hence, when it's the smallest element, then everything will go to the right subarray, which will cause inefficiency. Yeah. So this quicksort algorithm can be inefficient for small data sets, or data sets with many duplicate elements, as it would be hard to sort them out. And the worst case time scenario is also a concern, but that's very rare when you select a pivot by random. Yep. Next, I'll be moving on to the merge sort algorithm.